So, how do you figure out who was eating who almost 400 million years ago? You could look for bite marks, or you could study fossilized stomach contents, or you could take a piece of fossilized poop, put it in an incredibly powerful X-ray machine, and see what's hiding inside. And that's exactly what a team of paleontologists just did. Now, this new batch of fossilized poop comes from a newly discovered vertebrate locality in the Kamushka Formation of northern Taman. And they date to the boundary between the Middle and Late Devonian, the great period of fish, right? This was long before dinosaurs had come around. Now, researchers had collected several rock samples from the site containing something particularly interesting. They found a lot of coprolites, or in less scientific terms, they found a lot of fossilized poop. And these weren't just funny fossils. They contained evidence of what ancient predators were actually eating. The problem is that you can't simply cut a coprolite open. You risk destroying it and the tiny fossils preserved inside it. So the researchers used something called propagation phase contrast synchrotron microtomography. Yeah, I know. It's basically just an extremely powerful form of X-ray scanning. But it allowed them to kind of look through the fossils in 3 dimensions without having to physically cut them apart. They could then digitally isolate the contents and essentially pull an ancient animal's last meal out of its poop on a computer. And those meals were surprisingly diverse. The researchers found abundant remains belonging to lungfish and acanthodians, an extinct group of jawed fish, often nicknamed the spiny sharks. Even more interestingly, some of those remains belonged to juvenile animals. This means that the prey weren't all occupying exactly the same position in the ecosystem. Animals from multiple trophic levels were turning up inside of these coprolites. And this suggests that whoever produced them wasn't specializing in any one particular prey species. Instead, the evidence points towards opportunistic predators eating different animals whenever the opportunity presented itself. Identifying the exact animal that produced a coprolite can be extremely difficult. Now, earlier work on this material suggested that it was large predatory fishes, including relatives of the Eusthenopteron like osteolipiforms. But we can't simply look at one of these coprolites and confidently say, this animal pooped this. A skeleton might tell us that an animal existed. It's a coprolite that can tell you what that animal was doing and how it was behaving in the environment at the time the animal was alive. Sometimes the most revealing fossil isn't a spectacular skeleton. Sometimes it's poop.